Hi everyone, welcome back to the workshop, and it's part 2 of the HP 4338A Milliohmmeter repair. Now in part 1 video you saw me basically take the unit apart and recap the board, and we recapped quite a lot of the capacitors, the electrolytic capacitors, because they all showed either signs of leakage or bulging. So I'm quite happy that I've got like 90 or 95% of the capacitors recapped on this board. I just haven't done the big ones. I think they are fine measuring them in circuit. So in this part 2 video we're going to try and nail down that fault whereby it runs fine for a while, then all of a sudden it'll jump to a high number on the display and almost lock up, but not quite, and there's no recovery. You have to turn the power off and back on again. Now as you can see here, I've already done some work in setting things up. I've managed to remove the digital board, as you can see, and flip it up onto my PCB grip, and then I've used some ribbon cable extensions to bring back the connectors on the digital board back onto the front panel. So the whole unit is now 100% working, and it'll allow me to probe down on the analog board and try and find out where the fault lies. Now of course the problem could be up on the digital board. I'm going to measure the supply lines with the oscilloscope, make sure they're all okay, as well as probing the A to D chip, the AK9201A. Right, what you're looking at is a schematic, but it's not a schematic for the 4338A. This just happens to be another schematic for a completely different device that uses the same AK9201A A to D chip. And believe it or not, this is a schematic for a Roland keyboard synthesizer. The only copy of a schematic on the net that I could find that shows the AK9201A. So let's just go over it as far as Roland's concerned and how it uses it, and see how it actually works. So it's a serial A to D, meaning it doesn't have a bus, an 8-bit bus output or anything like that. It sends its data out on S-data, this pin 15, and you can see in this case it goes away off onto a control circuit somewhere, probably a microprocessor. And in this case the data is clocked out of the A to D via this signal here, hex inverter, and into the S clock pin. And because it's a 2-channel device, you can see down here analog input left, analog input right. You can see that the channel's also selected via this left right control here, again coming from a processor somewhere. Top and bottom you've got the analog and digital supply lines. It's got 4 supply lines. It's got a positive supply for the analog and digital circuits and a negative supply for the analog and digital circuits. And in this case it's a plus and minus 5 volt supply. It's slightly split via this 10 ohm resistor, a little bit of filtering just to keep the two sides a little bit separate there. Up here we've got the VREF circuit. In this case it's getting a positive 4.8. You've got a voltage divider here, positive 4.8, a voltage follower and a capacitor, and into the VREF there. You've also got the main clock for the device. In this case it's running at 25 megahertz, going straight into the clock input. And what you've got here is a one-shot monostable, and what that's doing is taking a fallen edge on this CCMA pin coming into the monostable and delivering a 2.5 microsecond pulse on its Q bar output, and that goes into the hold pin on the A to D. And what that is for is you want to instruct the A to D to stop converting in order for it to take its sample and send its data in its digital format on the S-data output back to the CPU. You've also got a number of control logic down here. In this particular case on the Roland, none of them are actually used. Now in the HP 4338A, I think things are slightly different. On the Roland, the clock is an input. The external processor will clock the data out from the 9201A. Basically, the processor is the master and the A to D is the slave effectively. But I think on the 4338 things are reversed. I think the S clock pin is an output. And the reason I think that is because I've been onto the board already and traced it out, and this S clock pin goes away off to the clock input pins on two shift registers, 74HC595, and I can't find anywhere else on the entire board that pin 14 connects to. So there is the AK921A, there's pin 14 there, that S clock pin. So let me set up the scope and we'll probe that pin and I'll show you what I've found. Now the AK921A in this case has the same plus and minus 5 volt supply. So let's just go round those 4 supply pins that I mentioned earlier. So pins 1 and pin 23 should be negative 5 volts. Yep, 2 volts per division, perfect. And pin 23, 28, 27, 26, 25, 24, 23, negative 5 volts. And on the positive side, pin 7 and pin 25 should be plus 5 volts. 4, 7, there's positive 5 volts in pin 7. And pin 25, 28, 27, 26, 25, positive 5 volts. So the supply lines are perfectly okay on the AK9201. And if I go on to pin 14, that S clock pin that I mentioned earlier, you can see that's a nice clock signal there, a nice 5 volt signal. But let's just leave it like this and monitor that pin 14 and see if anything changes. Now it can take a while, as I demonstrated in the last video, so I'll leave it hooked up like this and I'll come back when things change. And there we go, if you look at the scope, that's pin 14, that clock signal, and it's still there, but look at the voltage. It's dropped right down. And you just saw it go back up again and back down again. So whilst it's in this bad state, let's take a look at the supply lines to the A to D. Oh, there's pin 1. That's supposed to be minus 5 volts, and as you can see, it's very slightly positive. And we've got 2 regulators here that are providing the plus and minus 5 volts for the AK9201A. This is the positive one and this is the negative one. So let's get the multimeter on them and see what they're doing. Right, I don't know if it's working at the moment. That looks like positive 5 volt and the input to it is positive 11.7. And on the negative one, it's supplied by minus 11.8 and its output is minus 5 volts. So let's just wait for it to fail again. And there we go. The positive 5 volt one has dropped down to positive 2.8. Well, what's the input? Haha, 4 volts. No wonder it can't regulate. And what about the negative one? There's the output, 0.6. It's supposed to be minus 5. And its input, 0.7 volts. So we're losing the plus and minus 12 volts. And those supplies come from the DC to DC, if I remember correctly. So is it working at the moment? No. So let's go and see if we can find out. Yep. Now before I rip out the DC to DC converter, let's just check the supply to it. Now at the moment the supply is working. So down in here, positive 16.6 volts. And both the red and the yellow wires. And I think the black wires are just 0 volts. Yeah. Single supply to the DC to DC. So let's wait for it to fail again and then I'll check that input. There we go, it's failed. Has it gone back again? It's just come back just as a way to measure it. There we go, it's failed. So onto that supply to the DC to DC. Yeah, it appears to be okay. It's modulating a little bit. That'll be because we're losing load on its output. Yeah, -5 and +5. Oh, they're back away again. Well, it looks like at the moment we've got a problem with the DC to DC converter. Right, and here we go. Now I did take a look in here in the last video, and I thought the capacitors looked okay, although I didn't measure them. But there were some comments in the last video that a couple of people noticed that there was possibly some residue down on the circuit board between the capacitors. If you look closely down in there, it looks like there's some brown residue down there on the circuit board. But actually it's rectangular shape. It's not a blob as such. And what I think that is, it's adhesive tape that's used to hold the capacitors to the circuit board when it's being assembled, because this is a double-sided board. But anyway, I think we'll just have to take the board out and take a look on the underside, and perhaps we'll just go ahead and recap all the capacitors. You can see all the top side components there, and in the underside there looks to be a lot going on. Quite a few jumper wires, as well as input and output terminations there. A quick scan over the board. There is one or two joints that possibly could be a problem. This one down here is kind of missing some solder. This one here might not have a lot of solder. But other than that, it doesn't look too bad. I think the first thing I'll do is just check out these caps. Let's get the LCR meter on them and let's see what sort of state they're in. Right, I'm going to check these two down here. They're in parallel, so they should look like one big capacitor. They're, what size are they? 330 microfarad, 35 volt. Oh, we're getting 636 with an ESR of 0.4. That's not too bad. Yes, and those two look to be on the input side of the DC to DC, because we've got the lead here coming in and the capacitors are on this side of the board. These ones will be the output side, and they're probably in pairs as well. So let's just see what we've got there. What size are they? They're the same size, 330 microfarad. Yes, and they are paralleled up, I can see it. Getting about nearly 1,000. That one's 314. That should be 330. And this one here, 320. Now I'm measuring them in circuit, but I don't see any problem with just replacing them all, and we'll take it from there. Ah yes, those two there are 470 microfarad each. That's why we were getting nearly 1,000. And these two are 330. 470 25 volt, 330 35 volt, and these two input ones as well are 330 35 volt. Well, I do have some new capacitors. I've got some 470 25 volt, and I've also got some 330 50 volt. I think they'll do. I've changed out one other capacitor on the DC to DC, and this is this 4.7 35 volt electrolytic. And yes, on the LCR meter it's measuring about 10 nanofarad, and I suspect this one is on the control circuit supply on that DC to DC. But anyway, I've changed out all the electrolytics from DC to DC, so let's see where we are now. Okay, so I've hooked up the actual heatsink bracket now, so I can switch it on long term. I've still got the voltmeters hooked up. So let's put power on and see what it's like, and I'm going to leave it for as long as it needs to be in order to make sure it's stable or not, or indeed have we still got a fault. So let's put power on. There we go, plus and minus 12 volts. I'll just let it sit. Well, heat or cold doesn't seem to make any difference. Now I have checked, I'm getting a good 16 volts. Oh, wait a minute. Wow. Is that a bad crimp? Huh? Looks a little bit like a dodgy wire at the DC to DC end. It's not the output, is it? It's either the output or the input wiring on the back of the board. I don't think it's the connectors. No, it's not the output end. Try the input end. Oh, maybe. Well, I think I might have fixed it. What I did find was, when wiggling this input wiring around, it seemed to bring on the problem, or it did anyway, and I wasn't sure whether it was this end at the connector onto the board or the wires going on to the actual underside of the PCB. So I thought, well, I'm just going to sort it out properly. So I cut off the old connector, and because the crimps in there looked a little bit tarnished, and I've just replaced them, new crimps, new connector. And then what I did was, on the underside of the board, I just gave it a real good stiff clean with my PCB brush and some IPA, and really went to town on it and gave it a good clean. And now it's been running for about an hour and it hasn't failed at all, and I can wiggle these wires around, do all sorts with it. I've been over the circuit board with my prodding stick, moving every component, tapping on every component on the top side and on the bottom side, every single component, resistor, capacitor, IC, transistor, the whole lot, and it just seems to be rock solid at the plus and minus 12 volts there. No problem whatsoever. So I think it might have just been contamination on the underside of the board, and maybe moving those wires around moved that contamination, and it maybe stopped the oscillator circuit or something from working, and that's what shut down the plus and minus 12 volts. So cleaning the board is all it needed. So I'll leave it for another hour just to see if anything else happens. I'll move some stuff around, see if I can get it to fail. If I can't, I'll box back up the DC to DC converter and install it back in the meter properly. Well, there it is, up and running again, all boxed up, and I've got my 50 milliohm resistor attached, as you can see, and I've been running it for about an hour and it's just been perfect. It should have failed by now if the problem still existed. So I'm going to call that a win. Now, I don't have a milliohmmeter in the workshop, so this will be a useful little addition. However, I do have some longer term plans for this unit. You might have noticed the LCD is not the greatest in the world, especially since it doesn't have backlighting, and these indicators here are not the easiest to see when you select or deselect some of the functions. So what I'd actually like to do is do a TFT, a colour TFT conversion of the unit, much like I did to my Advantest R6581T multimeter. and having a look inside the front panel at the electronics that drives the LCD, it looks very similar to the 4338A multimeter. So I might try and do both, but that'll be for another day. So thanks for watching, and remember, you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. Thanks for watching.